Welcome back. In the second half of this video, we're talking about equations that are quadratic in form. And by that I mean they're not actually quadratic equations where there's a constant term and an x term and an x squared term. But if we did a little bit of a substitution, we could rewrite them as a quadratic equation. So in other words, we're talking about equations where there's a constant term, a term where there's some sort of an expression, and another term where that expression is being squared. So an example of that would be here, x minus 8 root of x plus 15 equals 0. Technically, this is a radical equation. We have a root, so we could use the techniques from the previous video to solve it. But one thing that we might notice is that this is kind of like a quadratic equation in that we've got a constant term. We have something, the root of x, and that same something that's been squared. X is the root of x after you square it. And so if we did a little bit of a substitution here, we could rewrite it as a quadratic equation. If we were to say letting u replace root of x, then if you squared both sides, that would mean that u squared would be equal to x. So in other words, the equation that we have really could be rewritten as a quadratic equation in terms of u. The one caution that I have here is don't forget that once you've solved for what u is, that's not your final answer. You're not interested in the values of u. You're interested in the value of x. So you will need to then go backwards and say, well, if u is this value, then what is the value of x? And we're going to work through several of these examples. So I'm going to do this one, the one that we're just looking at now. So we are going to make our substitution where we're going to replace the root of x with u, which means that x would be u squared. If we squared both sides of that equation, root of x equals u, then you would get x equals to u squared. So now our equation could be rewritten as u squared minus 8u plus 15 equals to 0. And now we just need to solve for what u is. This factors fairly nicely. We have u minus 3 equals to 0 or u minus 5 equals to 0. So either u is 3 or u is 5. Now again, don't be too excited and stop there and say, great, we found our answers, because remember, we weren't looking for the answers for what is u. We're looking for the answers of what are x. And so we need to go back and say, well, u, we were saying that that was what square root of x is. So instead of saying u is 3, I could say square root of x is 3. And instead of u is 5, I could say square root of x is 5. And now I can solve for what x is by squaring both sides. This is another little warning, of course. If we're squaring both sides anytime in our lives, we should be checking our solutions to see if they are extraneous or not. So I find two values for x, one value being 9 and one value being 25. And I'll leave it for you as an exercise to check this, to check that 9 satisfies the original equation and that 25 satisfies the original equation. I did my checking before making the video, and I feel confident in my answers, but I'll leave it for you as an exercise to check those solutions. So my solution set contains just the values of 9 and 25. Okay, next one. Here, this is something again where it's quadratic in form in that we've got a constant term, we've got something, and that same something is being squared. So if I were to replace the something, if I were to replace x cubed plus 1 with u, then that would mean x cubed plus 1 squared would be replaced with u squared. And so that means I'd be able to transform this from being kind of quadratic in form into being an actual quadratic equation. I would have u squared plus 6u equals to 7. And now I just need to solve. Bringing the 7 to the other side, factoring. So I have that u plus 7 is 0, or u minus 1 is 0. So I have the conclusion that either u is negative 7 or u is positive 1. And then, of course, we need to go back and find out what is x. So if u is negative 7, and we said that u was the same thing as x cubed plus 1, then x cubed plus 1 is negative 7. Similarly, if u is 1, then x cubed plus 1 is equal to 1. And now just solving for x. Bringing the 1 to the other side gives me negative 8. And if x cubed is negative 8, then x should be the cube root of negative 8, which is just negative 2. If x cubed plus 1 is equal to 1, that means x cubed would be equal to 0, or that x would be the cube root of 0, which is just 0. Now, I didn't square both sides at any point in this question, nor did I raise it to any other even power, which means I shouldn't have any extraneous solutions, but still it's good practice to check your solutions. Both 0 and 2 should solve the original equation, and in fact, if you check, you'll find that they do. So our solution set contains two values, 0 and negative 2. One more, and this one is maybe slightly less obvious as to it being quadratic in form. And so this is something where I'm just going to make a little note on the side. If you were to take x minus 1 to the power of a quarter, if you were to square that, that would be x minus 1 to the power of 2 quarters, which is the same thing as a half. In other words, this term, x minus 1 to the quarter, if we square it, that gives us this term, the x minus 1 to the half. So I'm thinking about, what do we have here? We have a constant term, we have a something, and that same something being squared. So we can do a substitution to turn this into a quadratic. I'll replace x minus 1 to the quarter with u, and if you square both sides, that means that u squared should be x minus 1 to the 2 quarters, or in other words, x minus 1 to the half. So we have now u equals 12 u squared rather equals 12 minus u, bringing everybody to one side and solving. We factor, and we have that u is equal to negative 4, or u is equal to positive 3, because u plus 4 is equal to 0, or u minus 3 is equal to 0. Okay, so we have the values of u, now we just need to find the values of x. So let's continue on. U is the same thing as x minus 1 to the quarter. So if u is equal to negative 4, then x minus 1 to the quarter is equal to negative 4. Similarly, if u is equal to 3, then x minus 1 to the quarter is equal to 3. I am going to just sort of pause here to say one thing, which is you can sometimes notice things that will save you having to do a little bit of busy work later on, and this is one of those places where I notice something. Because if we're thinking about power of a quarter, what is that really? Oh, that's a fourth root. We're really talking about the fourth root of x minus 1 being negative 4, and the fourth root of x minus 1 being positive 3. And so one thing we should note here is that for any even root, remember, even roots only give you positive outputs. So if we're thinking cleverly, if we're thinking wisely, we should know that whatever we get out of this will actually not be a solution, because there shouldn't be any value of x that when I subtract 1 and then take an even root will now give me a negative number. But I'm going to pretend that I didn't notice that. I'm just going to work as though I was just working mechanically. And so if you wanted to get rid of those fourth roots, then you know what you would need to do, which would be to raise both sides to a power of 4. So if u was 3, then that means the fourth root of x minus 1 is 3, which means that x minus 1 is 3 to the power of 4, or 81, which means that x is 82. And if we do the same thing with the other one, raising both sides to a power of 4, we would have x minus 1 equals to 256, or that x is equal to 257. Now, this is the spot where we're going to need to remind ourselves that since we raised both sides to an even power, it's not just raising things to a square, but raising things to a power of 4 or any other power, will require us to check our solutions, because raising both sides to an even power means that maybe one of these solutions might be extraneous. And so that means that we would need to check our solutions to find out, does it make left side and right side equal to each other? So if I check x is equal to 82, for this one, and I'm going to leave this as an exercise for you to do, you'd find that the left side and the right side will be equal to each other, which means that 82 would be a solution. But when you check the value of x being 257, you find that the left side of the original equation is not equal to the right side of the original equation, which means that you would have to reject that solution of x being 257. So that means the only solution to this equation should just be the single value of 82. Now, one last thing to work on here is solving rational equations. So again, equations with rational expressions. This is the same as what we did in the previous sets, and the premise is exactly the same. We're going to multiply both sides by the common denominator of all of those rational expressions. And of course, if we wanted to know what is that common denominator, we would have to do some factoring. And on the right side, that factors as x minus 2 x plus 1. So we would need to multiply everybody, left side and right side, by x minus 2 x plus 1. So left side has been multiplied by it, and right side is being multiplied by it. And the whole purpose of this, of course, is to get rid of our denominators so that everything will be nicely on one line. The x plus 1s here cancel. The x minus 2s here cancel. The x minus 2s and the x plus 1s cancel. So we're left with x times x minus 2 plus 3 times x plus 1 equals to 9. And then the only thing left for us to do is to now find our solutions. So I'll expand and simplify just as I always do. So we had x times x minus 2, that's x squared minus 2x. We had 3 times x plus 1, that's 3x plus 3. And the right side was 9. So bringing everybody over to one side of the equation and simplifying, I would have x squared plus x minus 6 equals 0. And I can solve by factoring or however I'd like. And I'm going to solve by factoring because that's easy enough for me to do here. X plus 3 is 0, or in other words, x is negative 3, or x minus 2 is 0, and therefore x is 2. Now again, I want to remind ourselves before we get very excited and stop and feel glad about our two solutions, we need to go back and think about what we did and what we didn't do, which is we never thought at the beginning about what are the excluded values in this equation. And there are two excluded values. Remember, for excluded values, those would be any values that make one or more of those expressions undefined. So if we're thinking about what's excluded, you cannot have a value of x being negative 1 because that would make the denominator on the far left 0 as well as the denominator on the far right. And x being 2 is excluded as well because that would make two of our expressions undefined as well. It would make their denominators 0. So what that means is that 2 can't actually be a solution. So notice, we found over here algebraically, we found a value of x being 2, but that value has to be rejected because it's an excluded value. And in fact, if you tried to see does it satisfy the equation, you'd find that unfortunately 2 makes several of the original expressions undefined. So even though we found two solutions, the only solution for the original equation is negative 3. So our solution set only contains just that one value.